Hello, my name is Manaf Asif, and this is Compass to College. Today we'll be talking about calculators on the SAT, some important tips and tricks, some useful functions on them, and which one you should buy. After that, we will go over some problems and solve them using the techniques we've learned in this class today. So we'll get started with the question, which calculator should I buy? So there's a lot of different options for calculators. Over here we have the 7 most popular ones that a lot of people will typically use. These are all Texas Instruments models, and the main problem with calculators is that they're relatively expensive, and so it's important to make the right choice and kind of think long term in terms of what you would want to use it for and what it would work for. So they've been arranged in this format in each generation. So as you can see on the very left is like the early 2000 generation. On the middle left, that's the early 2010s generation. The TI-84 Plus CE, the one that's by itself, came out in 2015, and the all the way on the right, that column came out in about summer 2019. And so each generation has some advantages and disadvantages as well as higher costs, and so that's important to consider. So first we'll be talking about CAS. So what is CAS? CAS stands for Computer Algebra System, and it's a system that allows calculators to perform more complex functions, and it can be very useful, especially on the SAT and many other tests as well. So let's take a look at CAS in action. So over here we have square root of 20. So in a typical calculator, if you plug this in, you would just get the decimal value. However, in this case, we see that the calculators have actually simplified it into a radical, and so we see it's 2 times square root of 5. And that can be really helpful for simplifying equations. Similarly, the CAS calculators know trigonometric identities. So over there you see sine squared x plus cosine squared x. That's a common Pythagorean identity, and that equals 1. Also notice that it can work with variables. So we didn't actually put in a value for x. We just put x there, and it was able to simplify that to 1 because that's the actual identity. Furthermore, it can be used to expand binomial and trinomial and however many polynomials you would like. And in this case, we have x plus 5 times x plus 2 times x minus 3, and it just easily expanded that into the full equation. And it's also been arranged in standard form with decreasing powers, which is a useful form. And furthermore, it can also be used for factoring. So I just took the same equation over there, put it back into the factor function, and it just returned the zeros. And similarly, on the right side, you can see we have a very long equation that's very disorganized. You have a lot of like terms, and when you put that in the calculator, it automatically sorts them and groups them by the variable and merges all the like terms together to give you a more clean output. And finally, you have a solve function. So on non-CAS calculators, you'll see the function called nsolve. That's different from solve because with nsolve, you'll end up with only one solution. And so in this case, if you did nsolve x squared minus 16 equals 0, you would probably only get either 4 or negative 4, which can be an issue because you want to get the entire solution instead of just one. And so that's why CAS can come in handy with its solve function. And there's multiple other functions, but these are the most common ones that you would use on the SAT itself. And this is definitely something to consider. So the main issue with CAS itself is that it's not allowed on some exams. So if you end up buying a CAS calculator, you might end up having to borrow another calculator, or you might end up being too dependent on the computer algebra system when you're trying to take these other exams. So for example, the ACT doesn't allow CAS, and so as a result, you should consider that if you want to take the ACT, then maybe you shouldn't get a CAS calculator. In this case, if we look back at the arrangement, all the calculators at the bottom row are CAS calculators, while all the calculators in the top row are non-CAS calculators. So now we'll be discussing the generational differences between some of the older and newer models. So as these calculators have progressed over time, they've slowly gotten more advanced, and so over here some of the main differences that you'll notice are a color screen, high resolution display. One of the most useful features is going to be the full-size keyboard at the bottom. On the left you'll see the TI-84 Plus Silver Edition, which is a pretty common older generation calculator. So as you can see on this calculator, you would have to hit alpha to type any letters, and it can get tedious, especially when trying to find the exact letter you want among all the other symbols. Each button on this calculator has multiple functions. On the right side, you have the TI Inspire CX CAS. It's almost identical to the TI Inspire CX in terms of the hardware. And so as you can see, this one has a full-size keyboard at the bottom. This can be useful when typing equations. So rather than having to hit Control or Alpha or something and trying to find the letter, you can just press the letter at the bottom of the calculator. Furthermore, you also have a touchpad. So it acts as a cursor. You can use your thumb or finger to scroll across the screen, and that can be a pretty useful function typically. One of the most useful features is going to be a backlit screen. So on the left, the screen is not actually backlit. That means that if the room is dark, then you're not going to see anything on the screen. On the right side, however, the screen is backlit, so that means that even in the dark, the screen has its own lights inside of it, so you can still see it. Also, the right side screen is clearly higher resolution. It's brighter. It's has colors. And so those are just nice to haves. Both calculators are relatively similar in terms of functions. However, the Inspire CX could save you more time in terms of navigating menus because it's a lot more user friendly, and it's better for beginners. However, if you're very familiar with the TI-84 or the TI-89, then those could still be an option. So one of the other nice to have features that you're going to notice between the older and newer generations is going to be the battery. As you can see on the left, the TI-84 Silver Edition has 4 AA batteries, while on the right you have a rechargeable battery in the TI Inspire CX. Alright, so now we'll be talking about some precautions to take when buying used calculators. So buying used is a pretty good way to get a good deal on these calculators because they're so expensive. If you buy them used, you can typically get maybe 50% off, which is a significant amount of money, especially at this price. So when buying used, you do have to be careful because of the longevity of the item that you want to maintain. You have to make sure that it hasn't undergone damage before you received it. So some things to remember when buying used are to inspect the screen closely. So try to look for pictures of the screen on and off. Look for defects such as like dark areas or scratches, things like that. You should also factor in the cost of a battery replacement. So if you're using the newer generation calculators with integrated batteries that are rechargeable, we have to keep in mind is that these batteries are charged almost on a daily basis. And so as with many other rechargeable electronics, the batteries tend to lose their capacity, and capacity is very important on a calculator. You don't want it to die in the middle of a test. And so as a result, a new battery is about $10. You should factor that cost in just to be on the safe side. Another thing you should do is to look at all the pictures thoroughly. One mistake that a lot of people make when buying calculators is they don't inspect the pictures closely, and when they get it, they realize that it's covered in scratches and they don't want it anymore, and that's something to just look out for. And finally, don't be afraid to exercise return policies. So on a lot of online sites, they offer return policies. If you get your calculator and within the return policy time, you notice that there's some issues, you should not be afraid to exercise your return policy because those issues may just get worse over time, and that could lead to it spiraling out of control and you could just lose your entire investment in this calculator. Overall, however, these calculators are a little bit expensive, so as a result, you could also look into other options such as borrowing them from your school. If you talk to your teachers and if they have some of these in their classroom, especially given COVID when they're not really using them in class, you can ask them if you'd be able to borrow it to prepare for your SAT. Just try to get it a little bit early so you can get used to the function of the calculator and make sure that you're very familiar with it so you don't encounter issues on the actual test day. So now we'll be discussing some useful functions of these calculators. Over here, I've got the TI Inspire CX2 CAS. It's essentially identical to the CX CAS in terms of software. It's just a few cosmetic changes, so it shouldn't be a big difference. And this is a virtual simulator that TI provides, and it allows me to teach you some of the functions. So we'll get started with if we go to the calculator page. So once we're on the calculator page, we just go to menu, and over here is a list of different categories of functions. And for the SAT, the most common ones you're going to use are number, algebra, and probability. So we'll run through the most important functions in each of those categories right now. So we'll start with number. In number, these aren't typically used. However, it's useful to know that they're over there in case you need them. I personally don't have an experience of using them on the SAT yet. However, if a question comes up that requires something like this, then it's useful to have it. However, things like greatest common divisor and least common multiple and factor as well are very useful for, of course, factoring. Sometimes in the SAT they also just ask you about directly what's the least common multiple and greatest common divisor. The other category is algebra, and so this is the category you most extensively use on the SAT. So the first function is solve. the way solve works is you essentially just put in your equation. You don't even have to use x. You can put in, let's just try t, for example. If you put t squared minus 16 equals 0. And as you know, this factors to t minus 4 and t plus 4, which means that the zeros are positive and negative 4, which we should see soon. And one thing to remember when doing this is to put comma t, because we're trying to solve the variable t. If you put comma x, you're not going to get the answer, and if you just forget it altogether, you're going to get this error, too few arguments. So it's important to know exactly what these functions each require when you're using them on the exam, or else you'll just be stuck on this screen and trying to figure out what's going on. So we put comma t, and your answer is going to be negative 4 and positive 4. So something common across all these calculators is that if you go over here, and let's say if I do 15, so this isn't going to return an integer value. If I put that, it's giving me the square root value. So this isn't the full decimal form. And so if I actually want the decimal form, sometimes it may also give like a quadratic formula type of output. But if I want the decimal form, I can just go back up here. If I do control enter, so if I go over here, control enter, that'll give me the actual decimal values, which sometimes you may need, sometimes you may not. On the SAT, they might just sometimes ask for the square root value. But it's important to know that you can get either output whenever you need. Some other important functions are going to be the factor function. So we'll just use the same example as I showed earlier, t squared minus 16. If you just do t squared minus 16, that gives you t minus 4, t plus 4. So notice in this case, you don't need the actual comma t because you're not solving for anything, you're just simply factoring. However, this form can be really useful for a lot of things, from graphing to finding zeros, but it can also be useful for simplifying expressions. So it's something important to keep in your arsenal, and it even works with more complicated factorings, like if you have 2x squared, or if you don't have the leading coefficient as 1, then it can get a little bit complicated, but this factor function acts as a crutch and just kind of assists you in factoring those kind of problems on the SAT. So now if we look back at the menu, we go to algebra and we see expand. This is the opposite of factor, and so if you punch in t minus 4 times t plus 4, then you should enter, and it gives you the expanded form. This can be useful if you just have 2. You can do it in mental math pretty easily. However, if you have 3 factors, then it can get complicated in multiplying the first one through FOIL and then multiplying the second one. It just gets very tedious, and so these are just useful functions to have. So now if we go back again, so one common trick that I find useful is that if you go to if you just hit menu, notice how these have numbers. Instead of going through with your arrow keys and trying to figure out what each of these are and navigating through the menus using the touchpad, which can get tedious, you can just type 3. Let's go back to menu. If you just hit menu, then if you hit 3, then you have your entire list there, and so you can memorize almost shortcuts. So if I want to quickly bring up, for example, I want to solve an equation right now, menu 3 1, there's your solve. And these can be useful for just saving a little bit of time. So let's get back to different functions. If you hit menu 3, and in this case we want to complete the square, number 5. Completing the square is when you add or subtract values on each side of an equation to complete the square to allow for a perfect square binomial factor. This is especially useful when you're trying to solve for a circle. You're trying to figure out what the center of a circle is and things like that. And so the way you would use this function is, let's try it with t squared plus 2t plus 1. And again, I missed that, comma t. And this is actually a perfect factoring already. In this case, let's try changing this to 2. Let's see how it reacts to that. So now in this case, you notice how it's saying that if I separate the 1, so I just get t squared plus 2t plus 1, then it'll factor to t plus 1 squared plus 1. So here's another really useful function. If you go to menu, algebra, and in this case we want to solve system equations. Over here, this allows you to solve a system equation with however many equations you want. So typically you can solve a system of equations by graphing it. If you have the variables x and y, you can just put it in the graph and then see where the intersections are, and those will be your solutions to the equation. However, if you have 3 or 4, then you only have two variables in the xy plane, x and y. And so you can't graph those to solve the equation. In that case, this is where this function can be really useful. As well as if you don't want to actually graph it and try to find the intersections, you can just put it in this, even if you just have 2. So we'll just get started with this. Here you can configure the number of equations. I'll keep it at 2 for now. Also over here, you can change the variable names. So one thing that I find useful is if, for example, I'm talking about apples and bananas, then I would change the variable letter to the objects that are referenced in the question. And so that just makes it a lot more intuitive to see when your answer comes out that you know, okay, A equals 2, so that means 2 apples were given, and B equals 1, so 1 banana was given, or something like that. And so it's just a small trick that some people use. And we'll just do a quick equation. 2a plus b equals 10, and b minus a equals 4. And if we just do enter, we know a equals 2 and b equals 6. So 2 apples and 6 bananas, or however it fits into the context of your question. So now we'll be talking about the probability functions. If we go to menu, probability, the first one we'll be talking about is permutations. So I'll briefly skim over the definition of a permutation versus combination. If you have 3 items, A, B, and C, how many ways can I select 2 of these items? Your options are going to be A, B, A, C, B, A, B, C, C, A, C, B. And so in permutations, all of these would be considered valid. However, with combinations, the way it would work would be AB is equal to BA, because they both have B and A. So combinations thinks they're equal regardless of their order. Permutation preserves the order. And so as a result, for combinations, the only unique ones you have are going to be AB, AC, CB, and that's it. And just 3. These 3 are just going to be your combinations, while you have 6 permutations. And so the way the function works on the calculator is that first you define the number of items you have. So let's start with, again, 3 items. Then you define with a comma how many items you want to take out. So in this case, I want to select 2 items from these 3 items. So these are the number of letters you would have in each pair, or triplet if you make it 3. But in this case, we just have 2, so we'd enter 6. So that was what we got over here. You have 6 options. And now if we go to combinations, probability combinations, so this doesn't care about order. So you do 3, 2, then you get 3, which is what we found over here. The number of combinations is 3, because these are just duplicates of these. And so it's important on the SAT to recognize when it's asking you to use a permutation, when it's asking you to use a combination. A lot of people get that confused, but this can be a very useful tool for quickly calculating these kind of things with just a very simple function. And finally, let's do the probability distributions. So the most common one you'll be using on the SAT are going to be binomial PDF and CDF. So we'll talk about PDF first. So the way binomial PDF works is it's a distribution that's based off of repeating trials that have the same probability of success each time. So for example, if I wanted to flip a coin 5 times and I wanted to see what the probability of me getting exactly 3 heads would be, that's the type of question where you'd use binomial PDF. So in that case, you would have 5 trials. So I flipped the coin 5 times, and each time I had a 50% chance of actually getting heads. And the value that I'm looking for, which is the number of times I got heads, is 3. I put that in, okay. That means that I have a 31.25% chance of getting 3 heads if I flip a coin 5 times. So binomial CDF works in a very similar way. You go to probability distributions, binomial CDF. In this case, however, it's lower and upper bounds. And so we'll do the same problem again. You have 5 trials. Probability of success is 5 because it's a fair coin. And in this case, I want to see what are my probability of getting either 0, 1, or 2 heads. And so in this case, 0 to 2 is going to be my bounds, lower and upper bound. If I hit OK, then my chance of getting 0 to 2 heads is going to be 0.5. And so these are both also very useful. You'll see them in repeated trial questions on the SAT, and it's important to keep them in mind. So now that we've discussed useful functions on the calculators, let's start solving some SAT level problems using these techniques. Alright, so here's our first SAT problem. This is taken from practice test 1, the calculator section. So it says a food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? So this is a very common type of problem you'll see on the SAT where this can be solved with two equations. So the first equation you would write is for the amount of revenue. So to calculate revenue, you would multiply, if these sell for $6.50 each, so $6.50 times the number of salads. So this will give you the amount of money generated from selling S number of salads plus $2, so 2D for drinks. This will give you the amount of money generated by selling D amount of drinks. So combining these gives you the total revenue, which is $836.50. Your second equation is going to be the total amount sold. And so in this case, it's total of 209 salads and drinks sold. So you just do S plus D equals 209. So this equation is relatively simple. You could solve it through substitution and a variety of other means. But in this case, we're going to show you how to solve it using the calculator, since that's an accurate way of solving it. And it may also be faster. To determine if it's actually faster, you'd have to experiment with it yourself and see how quickly you can do it, and if you make any mistakes. But so to get started, we start with menu. Hit menu. We go to algebra, and this is a system equation. So we go to solve system equations and just hit solve system equations. We have two variables, and what I like to do is I like to replace the variables names with the exact variables I'm using. So typically you could use X and Y. If I do S and D, then I know exactly what is a salad, how many salads and how many drinks are sold, and it just keeps it very clear and prevents me from making mistakes. So we do 6.5 S plus 2D equals 836.5. And now on the other one, we do S plus D equals 209. Enter, and there's your answer. So you sold 93 salads and 116 drinks. So in this case, we're trying to figure out how many salads were sold that day, and so the answer would be 93. So in this case, I wrote out the equation over here, and then I transferred to the calculator. On the actual SAT, you would be familiar with how to solve these kinds of questions using a system of equations. So you wouldn't have to write it on the actual paper. You could just directly go and punch it into the calculator as you're thinking of it. And so that's a more efficient way of doing it. So here's another problem. If the system of inequalities y is greater than or equal to 2x plus 1 and y is greater than half x minus 1 is graphed in the xy plane above, which quadrant contains no solutions to the system? So one way of doing this would be to just graph the lines themselves. So 2x plus 1 is going to look something like this, and half x minus 1 is going to look something like this. And based on that, you sample points in different areas and you determine where the solution is, where the solution is not. It gets a little bit complicated like that, and you tend to make mistakes. In this case, a lot of people might find it easier to just graph it. And so that's a big advantage of these types of calculators. You can easily graph these types of things. So I'm going to go hit on to go to the main menu. Then I can hit graph, and this opens my graphs. And one thing a lot of people don't know is over here, this is basically just y equals, and you type in the equation from there. But the problem is I don't want y equals. I want y is greater than or equal to. So how do I do that? Well, the trick is to just hit the delete key, and now you have a whole list of options over here. So relation is one that we might talk about later. But in this case, we'll just do y is greater than or equal to. Let's type in 2x plus 1. Enter. And over here, all this shaded part is the solutions. And if we hit tab, our box comes up again, and we can type in our equation. This time we have to type the whole thing, but that's simple. We do y, and now if we go over here, this symbol, if we hit control equals, it brings up this little menu over here about which symbols you would like. We want, in this case, greater than. And I'll just put 0.5 x minus 1. And now we have all the solutions for each individual equation as well as the combined. So the red represents the solutions of y is greater than 0.5 x minus 1. Blue represents solutions of y is greater than or equal to 2x plus 1. And where red and blue combine, that's purple. That's where both solutions are. So in this case, we're trying to find which quadrant contains no solutions. So if we look over here, in quadrant 1, there's solutions up here. In quadrant 2, almost the entire quadrant has solutions. In quadrant 3, there's solutions about down here. If we look in quadrant 4, there's no solutions. There's only solutions for this equation. However, we want solutions for both equations, which would be the purple area. So we can easily see that quadrant 4 is the one with no solutions. So that would be the answer. So now here's the next problem. For what value of x is function h above undefined? H of x equals this large equation. And so typically to find when this function is undefined, you want to look at, if it's a fraction, you want to look at when the denominator equals 0, because you can't divide by 0. And so what you'd have to do is you'd have to start expanding all of this, and then you have to set it equal to 0 and start solving from there using probably the quadratic equation. And that gets tedious, and you're prone to making mistakes on the actual exam, and it takes time. As a result, a lot of people find it easier to just use the calculator to do this. And so in this case, we'll go to home, we'll go to the calculator tab, and I'm going to be using the solve function, and later I'll also be demonstrating the end-solve function and see if that's any different. So the solve function is something that's exclusively available on CAS calculators. If you see here, this is a CAS calculator. And so what we want to do is we want to do in parentheses x minus 5 squared plus 4 x minus 5 plus 4 equals 0, because we want to see what value of x will make the denominator equal 0, and when the denominator equals 0, then you know that function h is undefined at that point. And this is one thing a lot of people forget. You have to put comma x because you're trying to solve for x, and that gives you x equals 3. And in this case, since there's only one solution, end solve should return the same result. We'll just try that really quickly over here. Algebra, it's called numerical solve, and solve. This is what's available on non-CAS calculators. You don't have solve available. The only difference you'll see is that we'll do x minus 5 squared. So the only difference you'll see is that it only returns one result. And so in the case of something like a quadratic equation where there may be multiple results, that could be a disadvantage. However, in this case, it should just work fine. See, the answer is 3. And so this is a free response question, so your answer would just be 3. So here's the next problem here. H equals negative 4.9 t squared plus 25t. The equation above expresses the approximate height h in meters of a ball t seconds after it's launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So one thing to note here is they're looking for approximately how many seconds will the ball hit the ground. The definition of ground is when the height is 0. And so as a result, you can just set h to 0, and then you can solve for t from there. If you want to solve this with a quadratic formula, you would have to do something along the lines of negative 25 plus or minus square root of 25 squared minus 4, negative 4.9, and then c is 0 over 2 times negative 4.9, which can get complicated to type into the calculator. Again, you're prone to making mistakes, and so as a result, this is something that can easily be solved. You can solve it both using the graph function as well as the end solve function or solve function. This only has one result, so again, end solve and solve will just return the same result. So if you go to menu, we go to algebra, solve, and then we can just punch in the whole equation. 0 equals negative 4.9 t squared plus 25t, and remember comma t because that's what we're solving for. Your answer is 0 or 5.10204. And so of course before it's launched, which is at t equals 0, the object is going to be at ground level, so that's not going to be an answer choice. However, 5.1 is a solution of the equation that is an answer choice, so that's going to be your answer. 5.1 is about 5.0, so that'll be the answer. It's rounded, so we can also solve this graphically. It'll take a little bit longer, so that's why I'd recommend learning about how exactly your calculator works, so that you can write as you see the problem. You can see the most efficient way of solving it, so you save the most time. So on the SAT, the more time you have to go over your mistakes, or any hard problems you have, or just review what you've already done to ensure that you haven't made any mistakes. So over here, here's our equation. So after we've typed in the equation, to get the zeros, you have to hit menu, 6, which is analyze graph, and then 0, set our bounds here and here. Your answer is going to be 5.1, and of course you have your other 0 at 0, 0. But you only care about the 5.1 because that's the answer choice. So over here we have another problem. This is a free response question. Over here you can see a graph that shows the number of portable media players sold between 2006 2011, and you have the number and the year that's on your graph. According to the line graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? So in this case, we want to see in 2008 what the value was, which is 100, and in 2011 your value was 160. So this is something that could easily be done in mental math, but I just want to demonstrate a useful feature that these calculators have. I believe all calculators I've shown in this video so far, including the older generations, have this feature. So in this case, you want to see 2008 over 2011, which will be 100 over 160, and you want to reduce this to a normal fraction. And so we could do this through mental math. However, if we go to calculator, if you just type in 100 divided by 160 and you just type enter, it'll give you the fraction right over there, 5 over 8. And so that's a good way of simplifying fractions. You can use it anywhere you need. And one thing I see a lot of people realizing on test day is they don't know how to get something. If they want the actual decimal value of this, if I just get the same value again, they want the actual decimal value, they type enter, they just keep getting 5 over 8. So how do you get the actual decimal value? So if we bring the fraction again, we just hit control and then enter, because you have a different sign over there that signifies that it'll give you the actual decimal value. So in this case, the decimal value is 0.625. And so that's something important to note, and that just shows why it's important to actually practice with your calculator beforehand, so you realize all these features as well as how to override the features when you don't want them. Since I've seen people in math competitions and tests that don't realize that this is a feature because they don't actually use the calculator, and they end up not doing very well because they don't know how to divide when they're not able to use the calculator the right way. So here's our next problem. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is a square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. So as you can see the table, it's just 10 plots, and we just have number in each plot, so it's just a sample. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground's surface in the entire field? So in this case, if we look at the answer choices, these each vary by a factor of 10. And so as a result, this is, as I mentioned in the question, an approximation. This is important because it means that we don't actually have to get the exact values. So as you can see over here, these are the values that were recorded for 1 by 1 meters squares. The actual field is a 10 by 10 meter. What this means is that the area of this entire field is 100 meters squared, while our samples are only 1 by 1 meter, and our area of these samples is 1 meter squared. So once we get the average amount of earthworms per sample, we can multiply it by 100. So over here, this is times 100 to get the average amount in the entire field. And so over here, rather than adding all of them up, this is 10 numbers and then finding the average of that gets tedious. What you can do is, if you quickly skim over it, you can see all these values lie between 100 and 200. None are beyond that range. So what that means is, if we quickly calculate the value for 100 and we quickly calculate the value for 200, we know that the answer must lie within the interval that we get using these values. And so if we quickly do that, if each one of these is 100, so then our approximations go from 100 squared to 200 squared. And what does that end up on our calculator? That's 100 squared is 10,000. 200 squared is 40,000. And so if we look at the answer choices, the only answer choice we see over here that lies between that range is C, 15,000. And so even though we just approximated this, we know that's correct because these are like the bounds of this. We know that the average cannot be beyond this because no single value even goes beyond this. So how can the average be beyond any of these values? And so that's a good way of approximating. So this also shows how you don't have to use the calculator how you may traditionally think you need to use it. In this case, what some people might think is that you have to add them up, as I mentioned earlier, and that'll take time, and that's what the question almost entices you to do by laying it out like this. However, the smart way to do it is to approximate as the question is asking you to do. And that saves a lot of time, and it shows how you need effective use of your calculator, not just brute forcing everything. Thank you for watching today's episode of Compass College. If you want to learn more about An-Nisa, you can visit them at an-nisa.org. If you want to learn more about the Humanitarian Benefactor Society, or HBS, you can visit them at hbsglobal.org. And if you have any questions, comments, or concerns, you can email them to me at masif@an-nisa.org.